Today we're going to be talking about something called mass points. So mass points is like a very powerful geometry problem strategy when you want to like find the ratio of like lengths in some figure. So it'll make more sense when we like actually do an example. And the concept of mass points is very like simple, and it's very like intuitive, like it makes sense. But it can still be used to solve very complicated problems and yield like non-trivial results. So first, like before we talk about like what mass points actually are, we're gonna first talk about some like basic definitions in some basic geometry terms, really. So let's say we had like some like arbitrary like triangle. If we call the triangle like ABC, let's say we put like a point D like anywhere on like side BC, right? Let's say we put it point D like here between B and C. Then you might sometimes hear this line AD. It's sometimes referred to as like a Cevian. You might sometimes hear the word Cevian. And like a Cevian is just basically any line from like one vertex of a triangle to a point on the opposite side. So like that's a Cevian. This blue line is also a Cevian. This green line is also a Cevian. So there are a bunch of like infinitely many Cevians, basically, or a Cevian or a Cevian. Not really sure how you pronounce it, but something like that. And that's the first important term that you sometimes might hear. And so clearly here in this case, this line AD in red, this is like a Cevian of the triangle. So if we were to like so let's just like redraw the triangle. If we were to redraw a triangle ABC and we had one Cevian AD, and let's say we had another point E somewhere over here, then BE is like similarly, it's like another Cevian of the triangle. And let's say we had a point F, then CF is also Cevian. So depending on where we choose these points D, E, and F, these three like Cevians, like this red line, this blue line, and this green line, they sometimes might intersect at one point. In this case, they intersect at this point here. Like all three lines intersect at one point. And in geometry, there's a special term for this. We say that if three lines all intersect at one point, we say that these lines are concurrent. And this is also a very important geometry term when a problem says that three lines are concurrent. That's just a fancy way of saying that the three lines intersect at one point. Yeah, so those are just basically like the basic definitions of like what of the important geometry terms that we need to know, like Cevians and concurrency. So now that we know the basic definitions, let's start talking about like the actual like idea of mass points. So mass points are basically like if you have a line, it's a very like intuitive like geometry problem strategy, but like it's also very interesting if you've never seen it before. So like if you have like a line AB, like, let's just first consider a line segment like AB, and let's say we had a point like let's say we had a point X in between, right? So let's say in between these 2 points we had like a point X maybe.
And really hard with those reverse change portals. Wow. Very
I think someone has their mic on. Okay. Yeah. So anyways, so if we had like this line segment AB and we had like a point X in between these 2 points, then we can kind of like the idea of mass points is we can kind of treat this line segment as kind of like we can kind of pretend it's like a seesaw, kind of like, on a playground, like when 2 people sit on a seesaw. So the idea is you can kind of pretend there's like a fulcrum at the point X, and you can treat AB as like kind of the seesaw. So like we know intuitively, right? If point X was like right in the middle, like if the fulcrum was like right in the middle, then like if you have 2 people sitting on the 2 sides, like if the 2 people have the same weight, then the seesaw is going to balance out, right? But if the point X, like the fulcrum, this place, if it's like not right in the center, then we might need to adjust like the weights on the 2 sides to like see like how to make the seesaw balanced, right? So if let's say like this length here was like, let's say it was a 1 meter length, maybe this length here is like 2 meters or something. So if the distance from X to A is 1 and the distance from X to B is 2, then if we wanted to like put weights on points A and B, then intuitively, if this length, if XB is 2 times XA, then in order for the seesaw to balance out, we would want to put a weight of 2 at A and a weight of 1 at B. So like this kind of like makes intuitive sense, right? If the lever arm here is like double here, then you want the weight here to be double here in order for like the thing to balance out. And this is like the idea of mass points basically. Basically, in like a geometry diagram, you can treat every line segment as kind of like a seesaw, and every point between that line segment as a fulcrum. And we can like assign different weights to the vertices and the points in the diagram, and then we can get like a bunch of interesting relationships. So like, and you can kind of see that in mass points, the weights and like the length ratios are kind of reversed, right? In the red color here, this is 1 and this is 2, but like when we actually assign the weights, is kind of, you can think of it as kind of, it's like reversed. Like here, the 2 is here and the 1 is here. So I'll just wait and see. Does anyone have any